Good morning, I'm Wai Yeung Yan, Assistant Professor from the Kong Polytechnic University. So today I would like to introduce some of the recent work done in Hong Kong regarding underground utility modeling using 3D point clouds, which is done by a tech firm called Lidarist. So today we will present our comprehensive AI solution regarding how to convert the 3D point clouds into the BIM model for the underground scenarios. So as we know, recording as-built records for underground utilities are always challenging. So time is always limited, and also it is not easy to access to the construction site and setting up surveying equipment. And as we know, Hong Kong is a very congested cities, so with the highest population. So that's why doing such a task is always like a headache. So what are the existing problems? In current underground utility record, especially those in Hong Kong, so most of the records are stored in 2D maps. So pipes are represented as 2D polyline features, valves are pinned as point features. Occasionally, elevation information can only be displayed in several intervals. Now with the technology advancement, we are able to use camera or 3D laser scanner to capture the instantaneous 3D scene of the underground pipes. As a result, all the details of the underground scenario, including the pipe, and the connection, the joints, and the elbows, and the blank box can be recorded. So finally, we can use all these 3D point clouds to convert into the BIM model to represent the underground scenario. So now we have the hardware technology. So do we have the need? So in Hong Kong, it costs 100,000 a million Hong Kong dollars because of the water pipe exposure. So one of the reasons is mainly because construction workers may simply rely on the 2D UU map, as I mentioned before, dig in the ground with the approximate location. Therefore, in Hong Kong, the government in 2021 begins to develop an accurate 3D digital underground utility database with a view to facilitating the construction industry to plan and conduct the underground works efficiently and reduce the roller coaster time resulting from the construction work.
I'm Kwan, CEO of Lidarist. When talking about LiDAR or laser scanner, I will describe the development as hardware over software. You can do a laser scanner in a few minutes, but you may take 10 times of the data acquisition to work on data or information extractions, mainly by manual interventions. The process will also involve missing informations, missing data, and any inaccuracy data by human errors. To speed up the process of information extractions and effectively to handle the unstructured point cloud data, we have applied deep learning techniques to automate all the process, at the same time retain the accuracy. As a simple interpretation, applying deep learning on point cloud data is employing a very experienced technician to tell you which points are belonging to which categories or classes. For example, in the underground point clouds of pipeworks, the technician will tell you which points are belonging to pipes, pipe fittings, valve, or even the connection. It's up to what classification or categories you have designed. So, to develop a deep neural network is like training up a technician to enable all the data with the deserved classes, and the technician can work for you in 24 hours. With the segmented point cloud, we can extract the points we want by their labels. For example, pipe fittings, or other pipe appurtenances. Point cloud is not actually the preferred data format that we want for recording or for storage at database. So we will apply the 3D modeling algorithm to reconstruct the pipeworks with the point clouds. They are the best fit modeled to describe the point cloud with these 3D pipe models. We will further simplify and convert them into an array of coordinates, which represent the center line of the pipe network. They consist of coordinates x, y, z, the outer diameter of the pipe sections, and the classes that we define.
So regarding the data acquisition, so one of the efficient methods is to use a 3D laser scanner or a LiDAR to collect the 3D data point clouds. The mechanism of LiDAR is a laser beam is emitted from the laser medium and which is hit by the plumb source. So when the electrons of atoms get excited, and then it will leave the reflective mirror and arrive inside the LiDAR system. So the LiDAR system usually equips with oscillating mirror or rotating prisms so that the laser beams can be distributed in different angles to the ground. Finally, when the laser beam reaches to the ground, it undergoes laser backscattering and provides a return. So by measuring the time of flight and converting it into range, the 3D coordinates of the illuminated surface can be estimated. And also some of the LiDAR system may equip with the camera. So therefore, the LiDAR point cloud, apart from having the 3D coordinates as well as the recorded laser signal strength, which is the intensity, we can also have an RGB value embedded in each of the data points. So to collect the 3D point clouds for an open trench area, we usually come with the LiDAR system, setting it at the end of the construction site, and then we will run in a zigzag way in order to have a better coverage of the entire underground utility scenario. And also, we set up survey marks on the underground water pipes in order to help later on to check the quality of the collected 3D data point clouds. So in Hong Kong, not only the consultant and the contractor collecting the data point clouds for the underground pipes, also the Hong Kong government itself did the data collection by themselves. So for instance, we receive and collect the data from Water Supplies Department with a 4 km long pipe work. So these data set includes 181 data sets, and within each data set, it covered 20 to 25 meters in terms of the pipe run. So therefore, we have a lot of 3D point cloud data for the open trench area that can help us later on to do the manual labeling in order to establish the training data set.
Quality checking for the captured point cloud is important. It ensures the source data is reliable in positioning accuracy. We will perform density check and positioning accuracy check before running any processing algorithm. With the coordinates of serrated control target taken by traditional underground utility surveying, they can be served as the ground truth of the corresponding point cloud. To make it an automatic process, we have trained up the new network models to recognize all serrated control targets within the scene. We then extract the coordinates from the serrated control target with their features like colors or intensity. The positioning accuracy can then be assessed by comparing the coordinate from point clouds and also the coordinates from traditional serrating method. For the density check, we simply computate the distance of the Lidarist neighborhood for every point. A histogram or a heat map can tell how the point cloud performs. With our developed approach for information extractions from point cloud, the workflow from raw data to deserve the information as well as BIM models can be automated. Here's a video showing the full workflows. one new network model is not capable of handling new data, new categories, or new applications. It is not a sustainable solution if the solution is with only one fixed new network models. Data is dynamic. With laser scanner, data increase over time with different kinds of underground pipe being captured. To cope with the ever-changing data, the solutions should be flexible and adaptable to new data. Instead of a fixed new network models, our solutions allow upgrading of new network for new data and adjustable for new applications. Replacing the complex coding, the system is also low-code and user-friendly, so that user can rechange the new network models with their own new data and making the process data-centric. With the three features, P-label, relabel cycle for new data, no-code platforms, and data-centric, the whole approach is sustainable to new incoming data. The solution can contribute the required underground piping information continuously. Our approach is filling up the gap and complete the process from data acquisition to information extractions. It's replicate the underground information constructions of a city and provide a detailed map of underground that's serving the future maintenance and renovation. At the end, we would like to give our special thanks to Water Supplies Department and Lands Department of the Government of Hong Kong SAR for their data, insight, and support. Also, I take this opportunity to thank the continuous support of the Hong Kong Science Park. Thank you.
Can you tell me a little bit more about Lidarist, the company? How did it start? Who are your clients? What types of projects are you working on today?
Okay, maybe, can you hear me?
Yep.
Yes. Yep. Yeah. Maybe we established in 2020, and we're focusing on developing deep learning solution on point cloud data, not only on underground point cloud data. We are also now working on some MMS data, mobile mapping system, for some raw inventory extractions. So underground is our first focus. And I can say that it's very mature now because we have been engaged in various contracts, working for some government departments, as I mentioned, Lands Department, Water Supply Department, and the trained models behind the pipeworks is very mature, and we have tested on various pipe materials, scenarios, and we have actually have a comprehensive solution for point cloud to BIMs and also for 3D GIS data.
Excellent.
Right.
Thank you very much. And how big is the company today? How big is your team?
I'll describe it. We're still at the beginning stage. We have 5 members total. Vincent Fan is our technology head. I'm the CEO. So there's various data scientists working for me. Yeah, working for us.
Great. Fantastic. Yeah. No, it's an exciting company. The presentation was really well done. We just did a LiDAR Canada event about a month ago, so I'm pretty familiar, even more familiar now than I would have been than before that, with different uses of LiDAR. This is a good one. Okay, everybody, the Q&A is open. I'm going to continue to lead us off. One of the questions that we had, what is the most critical concern for your clients to adopt deep learning in their workflows?
Okay. maybe I answer first and see if any supplement from Vincent or Dr. Yan. So data is also is always a concern. So training a new network requires a huge amount of data, and of course a huge amount of workforce to labeling the data. You know, we need training data to train up the new networks who can work for all the scenarios. So in fact, in traditional workflows, the labelings of training data will take up maybe a % of our project cost. So this is also we come across at the beginning of our service contract. So, however, we have as I mentioned, this is a pre-label and relabel working cycle, which means that we would train our initial new network with limited data, with limited training data, and then we try to upgrade to new network models with updated prediction results. So this methods will speed up the process to train up all the data. For example, in one of the projects, we have received 5,000 of data, and you can call it impossible to label all the point cloud data, all the 500,000 data. But with this workflow, we can speed up all the process to train up the new vector, which is capable to handle the 5,000 of data. So I would say that it makes the use of new network more acceptable.
Great. Is there a follow-up? Something I would ask is your training data sets, where are they coming from?
Mainly it's from when we are working for water supply department, they have already have a practice to have some open up change point cloud data a few years ago. So they got their equipment themselves and they have a policy to scan all the SB record with a scanner or photogrammetry.
Okay.
Yeah, and then we get all the data together. So we partner with Lidarist. So we spend some time to do manual labeling in the beginning stage, and then we, as Leo just mentioned, so we keep like label, relabel in order to improve the network. So that's why like in the beginning it is tough, so it is tedious. So we spend lots of effort to do manual labeling, but right now we are doing great. I believe like we get some good training data set on hand, especially for Hong Kong right now. Yeah.
Okay, great, fantastic. Okay, a follow-on question. What is the greatest challenge in automatically generating BIM or 3D models for underground utilities?
Okay, I think I'll take this one. Thank you for the question. So the greatest error in our previous experience is that measurement error. So last year for the SUMSF 2022, we talk about putting arrows in mapping the underground world is about tens of centimeters for the highest accuracy requirements. But this arrow is actually quite large for underground utility BIM modeling. So when you see, say, for example, the two endpoints of two pipe sections, you see there would be half a meter difference. How could you align them? How could you integrate both models of different scan stations or different work sections? So that's for manual work, you can do that manually. You can fix that error, fix that to make the 2 points, the two ending part join together. But for the automatic modeling, you need to fix the error. You need to know whether it's elbow here is missing. Maybe they forgot to scan it, or maybe there's some kind of missing. Maybe the workers still haven't installed that at the time of the scanning. So we need to fix that error. In our previous experience, we know the semantic labels. So this basically tell you which point are part of the pipes, or which part of points are part of the elbows or valves, different kind of appurtenances. So we know what kind of component we should add at a specific section of the pipes. Therefore, we can get a precise location of those different components. We can we don't care too much about those errors, so we can fix that. And this also helps us to reduce the time because we no longer need manual works. We no longer need manual editing. You just give us a point cloud and we give you the models. That's fully automatic. Sometimes you might still need some adjustment because, you know, in survey work, sometimes the misalignment might be a meter or even higher, because especially when you are using photogrammetry, but we can deal with most of the errors.
Great, thank you. It sounds like you're continuing to work quite strongly with the government in Hong Kong.
So Hong Kong is just a starting point. So as Dr. Yan Liu mentioned, the most difficult part is the data. So from the beginning part, we need to label every data set. And then we developed some image-based algorithm or some other different algorithm to speed up the labeling process. So our labeling process is become faster and faster. And then, for example, we now have different size of pipes, different color shapes. We can now apply the model we have, the training data we have, to different kind of data. For example, we recently got a trial from a drainage department of Hong Kong. We use the data we got from the water department. They're both pipes, but different size, different color, different, I would say, different certain kind of different shape. But we can use that model onto their pipes, onto the drainage department pipes, and to get the model directly. We no longer need any training data. So that's a starting point. So I would say if we if there's a customer in the United States or Canada, we can directly apply our model onto their data to get the model directly. No longer training data needed, or just a little amount of the training data. So that's why it's now much easier compared to the starting point.
Great. And if there were organizations or individuals around the world that wanted to try out this new technology and have a look to see how it did with maybe some of their own data, can they just reach out to you directly?
Sure, no problem. I think we have the QR code in the video, and we also have the emails, and you can send the request to any of us, and then give us the data. We can do a trial, and then we get the result to see if you are satisfied.
Who do you think would be an ideal, not customer, potentially a customer, but like, who do you think, is it like is it a utility somewhere else, or is it a private company managing a utility, public or private, as I guess what I mean?
That depends, I would say. For Hong Kong, for the cases in Hong Kong, Hong Kong government now requires every project to have BIM. So that means when they are laying the pipes on the ground, they need to scan all the pipes. They need to build the BIM model. That's why they're no longer doing that using a roller pole to do the measurements. They use laser scanning nowadays. But for those private companies, private pipes, for example, those pipes in the utility room, like the house underground, if you want to do some renovation, you can use our system to get a model, to get BIM, but not so economic friendly, because you won't do that to a house. But if you own a building, for example, those condos in Toronto, you might need to get those pipes before you want to do the renovation. And another case, it would be the drainage, the rainfall drainage system in Toronto, for example. You might need to do a precise model for them to calculate the water flow or different directions, where are they going to go, or Is there going to be something underwater? Do you need a fix? You're gonna need a precise models. You're gonna need the radius of the pipes, the tilt angle of the pipes, direction of the pipe, many things. They need precise model. So I think those not so precise data, if they cannot fit your needs, you need precise model, you need BIM model, you need to come to us.
Great. Yeah, there's so many areas where this, scan to BIM is so useful. I was talking to an individual in Vancouver, and he was putting together a system for cruise ships. So he used to be an officer on a cruise ship, and they wanted to scan the infrastructure of the ship in order. They needed to deal with, updates to the systems, changes to the systems. This could be very useful in situations like that as well.
Yes, yes.
And one more thing I would like to supplement is it all starts from the government policy. So as Vincent just mentioned, so in Hong Kong, the Hong Kong government issue a new policies. So for all the works infrastructure causing more than 3.8 million US dollars. So all the contractors and consultants are required to submit the BIM. So that's why it triggered a new market here in Hong Kong, especially for scan to BIM. So that's why consultant contractors, utility solution providers have to submit the BIM, especially for large scale infrastructure project. And that's why it comes up with all the tech firms inventing solutions from scan to BIM, no matter for underground or for the plant room and so on.
Yeah, that's a real incentive for industry to move on something, is when the government tells you you've got to do it.
Exactly.
Yeah.
Exactly. Yeah.
Yeah, I do remember that from the talk last year. It was really interesting to hear about the regulatory framework there in Hong Kong. Jeff Zeiss was always contacting and talking to people all around the world, engaging with them on what was going on in their different parts of the world, and then connecting them together. And that's how you gentlemen, it's through contacts over the years with Jeff Zeiss and engaging with him and us at the event. Thank you so much for being a part of this.
Thank you. Thank you for letting us have the opportunity.
Sure. Is there any last messaging that you want to leave the participants?
All data are welcome, I would say.
So you'd like to hear from people, get them to send you their data and engage.
Yeah, that would be great. If anyone wants to have a try.
Great. Well, we'll also help with that. Get message. We do post-event messaging and